Welcome to the session about Longhorn. And I'm Devico. I attend the QCon's couple times. The main mission for me is promotion Longhorn to have more adoptions around the world. Okay, so I'm engineering director at SUSE and leading the Longhorn teams working on that together with our external contributors. Okay, so the agenda is I will talk about Longhorn overview, and I assume some of you maybe not use Longhorn right now, or maybe consider using Longhorn. And some of you already using Longhorn. I will talk about more about plan later, okay? So after overview, we'll go over the project status updates and the release updates. And the next important part is about the Longhorn details. So you will know more about how Longhorn works, how simple it is, and from design, from the operation, and to the day two, and whatever you want to measure Longhorn in your cluster, including the few subtopics, architecture and capacities we have, and one item I want to independent highlight is a V2 data engine. So this new one, we are spending a lot of effort on that to let the Longhorn capacity, especially for performance, jump to the next levels. Okay. And about release, and we already released 1.8 in January. So some of you maybe try, and 1.8 right now, the latest version is 1.8.1. It's the stable versions, so please give it a try or upgrade to it. Give us more feedbacks. And also the upcoming 1.9 in May, and there are a couple of new features and new ideas following, and we want to do in the following release. Okay, this page is a simply let a user note, especially for people you don't know about Longhorn. Longhorn is the distributed block storage solutions based on Kubernetes. So you can simply start from a cluster, install Longhorn chart, that's it. So everything there, because it will use your local disk by default. And secondly, you can provide highly available persistent volume, because with replica, we have more than one copies of data for your volume. But it's configurable, depends on your design. And the third one is not just persistent volumes. Beyond that, we also provide the in-cluster snapshot to make sure you can have a different time and different strategy to measure your local data for your volume. So also, we provide the external backup. So this is better fit if you have any strategy you want to measure your data outside. And the following storage based on backup is a cross-cluster disaster recovery, because you can leverage your centralized backup targets and restore your data to a different destination cluster. And Longhorn can run on any environment. What I say any here is more want to highlight is a platform agnostic. We have verified several environments on-prem, edge, private cloud, and public cloud. And you will always see sometimes in the Longhorn release, you will say, oh, Longhorn right now is verified for some distro, or right now, or Longhorn is able to run on the GCE, GKE, something like that, because we spend a lot of effort to let the Longhorn can run on different places. And for sure, he's a CNCF incubating right now, and we are looking for the community user for the more contribution, because this is one criteria I want to jump to a graduation. We want to see more contribution from outside. About the project status update, right now it's growing, continue growing over years. So many people like if you see a star from the GitHub, it's a traditional way we understand how popular the project is. And for the metrics, the metric we have public metrics. This is a metrics.longhorn.io. we can see the how many nodes around the world using Longhorn right now. It's growing. Overall, is more than 159,000 nodes run now. And most of the time, we have a new version. People just very aggressive to upgrade a new version of Longhorn to see and try the different new features. And in general, it's about 28,000 clusters in total. And from the feedback from the users, we know, of course, you can down to just one node cluster, totally fine for your development or local home lab. I know many people use Longhorn in the home lab. And also, from my current information, I know there's a few cases run Longhorn in the more than 400 nodes cluster for now. Maybe more, we don't know, maybe run on-prem. And the area, adoption area, home lab, edge, on-prem, cloud, private cloud, or public cloud, a lot. And for the domains, AI, telcos, data virtualizations, observation, especially less recently virtualization. We have, CNCF have another project called Kuber. And Kuber actually use a lot of users using Kuber in their Kubernetes stack. And if you want to make sure your volume for your virtualization VM running well, especially support the volume migration, Longhorn support it. It's a little different from the traditional rewrite many, but I will share more. And Longhorn will be adapted in the end user, service provider, or solution provider for now. Many cases share if you join the Slack channels, or if you have some discussion, you can raise your discussion or issue to let us know what you are working for and what domain you are working for to adapt the Longhorn for that. And of course, Longhorn can run on the nodes, run your Kubernetes using the traditional operating system, for sure. If you look into or read our documentation, you will know with each feature release, or even down to the patch release, we verify different type of operating system. And next important part I want to mention is immutable operating system, probably together with the Kubernetes distro. One from the community feedback, very strong feedback. A couple of times, they want the Longhorn can support Talos, Ninas. And in the past, we don't support that because we don't pay attention to this area. But right now, Longhorn is ready for that. Actually, not just for this version. We start from the couple view version before. But we continue verify when the Talos have a new version. When we're doing our release, we will verify that. Okay, so release update. Release update right now, the latest one, the minor release, it just happened January. And the latest release is 181 March and 173. We have a 1-year support period for community users. We are doing right now, try the best with the best effort to make sure we can catch up what the feedback, especially you encounter critical issue, critical challenge. We want to have a foreign patch for that. The most important part is the upcoming release is 1.9. It will be landing in by end of May. We are working on that. And 1.10 will be September. What I want to mention 1.10, because I want to introduce a release cadency the new way. We start from the 1.8, it's 4 months minor release cadency. So you can totally can be expect when you can get the Longhorn release, January, May, and September. So you can have a better expectation when you want to adapt the newer version. And maybe you don't need to wait for a long time. If you want to see, we are running the spring way. So every 2 weeks, we will have official the spring release. And every spring release will be just a tag, and we publish the image and ham chart, so you can try. Ham chart is not yet, but the image is ready, so you can try modify your manifest to get play around the new features. Come to the end of each sprint. Okay, so this is about the project status update and release. And of course, we have more. I really want to introduce how we work for the Longhorn project management. We adopt sprint, but today maybe the time is not enough. So we have a kiosk. If you are curious about the contribution, come to me, so I can discuss more about these parts. For Longhorn, this page we do some enhance. If you compare with the documentation part, right now it's just central parts. But we want to combine a few parts together. So for Longhorn, it's actually two primary parts, control plane and data planes. The main core part is we rely on Kubernetes customer resource and rely on the event for the Kubernetes built-in resource to understand what's happening for the workload and their volume request. And from the interface point of view, the interface for user, they can go with the Longhorn UI. When you install Longhorn, we will have Longhorn UI for that. It's very simple, straightforward, but it's not quite fancy because it's an old framework. But we are working on the new UI right now. It will take few release to make it ready. And also Longhorn CSI driver. And Longhorn CSI driver will deploy the CSI driver together with a plugin on every node to make sure we can listen to the code base from the Kubernetes to understand when to provision, when to resize, when to attach the volume, what we need to do. So, and underlay is actually Longhorn API, is RESTful, but it's not the official API to use publicly. So most of the time, if user come to me, David, can we use the Longhorn API or some way for the automation purpose? I say yes, but don't use a Longhorn API, use a Kubernetes customer resource. Because this is the general interface for you when you use not just Longhorn, you use other products as well, right? And when you operate and we know about what we need to do, we will be down to there's a component, it's Longhorn manager, he's a control plane. And we run every nodes, there's Longhorn manager. So we will know when we bring up the Longhorn volumes. Longhorn volumes compose of two elements. One is the Longhorn engine. It's the front end for your volume. And also his downstream replicas. Depends on how many replicas you want. And we will see, Longhorn will see how many available disks available in your nodes, and we will provision your replica to the right places, okay? And make sure it's available for your usage. And when your replica done, we will make sure it will be reviewed in the management time to make sure the replica will be compact because it will be get the data back from the healthy replicas. But if your replica just fail, but it can be reused, we will just let your failed replica come back and collect the missing part from the healthy replicas. So this is overall the control plane parts. So this part, should be this part. So data plane part. Data plane part is how the volume is actually make it happens. So we have a V1 and V2. Probably some of you don't know about the V1 and V2, but I just want to brief. V1 is current data engine we are using right now based on iSCSI protocol and homemade protocol for replicas. Okay, so if you look at the left-hand side, you will see, okay, Longhorn engine is bring up, and in front of Longhorn engine is actually the iSCSI target server on the user namespace. And with that, we use the iSCSI protocol to to make the device available for your workload application. And for downstream part replicas, we use our customized protocol based on the TCP to make sure the data traffic can synchronize right to the replicas. And also we come with a data locality capacity. So if one of the replicas together with your workload, together with your Longhorn engine, you will go with the Unisaki locally to make sure the more efficient. But still, it's an iSCSI protocol. So the performance is not quite high performance, high end. So in some case, most of the case, general case, Longhorn is run well. But if your application is very data intensive, and you are looking for the high performance, can be more step close with a raw disk, we need a different way. So this is why we have a Longhorn engine V2 we are working on right now. It's based on the SPDK storage performance development kit. It's just donated to the Linux Foundation recently. And most of people contribute to the project is Intel, from my understanding, Intel. And my team members also contribute because we want to make it be part of our new engine core, the core of our new engines. So the idea is actually based on the NVMe over fabrics to make the performance better. And we use the SPDK BDEF to file our Longhorn engine, new engine in front. And for the downstream replicas, we based on the logical volumes. The idea is from the SPDK. So we can provide the same capacity like a snapshot, and we can do the same capacity for the backup because it's also simple vision, the same as V1. And for the fun, how to represent for your workload, we use the NVMe over fabric. So you will see, okay, another device happens, and you can mount into your application. Everything is automated because it's a CSI driver. Our CSI driver will handle it. But on the other side, I want to mention another one we are working on right now. In upcoming 1.9, we try to make not just rely on the NVMe over fabrics. It's actually over TCP. Have a target server for that. We want to leverage UBlock. It's based on IOU ring, so have a more better performance for the front end. So he will come into upcoming 1.5, and we actually done some performance testing, and he will be jump another level if you compare with the NVMe over fabric. So let's say for V1 general usage, you have iSCSI protocol with a Longhorn default design for his engine and replica, and V2 will back on the high performance SPDK and have a different front end support for it, NVMe over fabric and UBlock. Okay, so we know about the control plane and data plane, what the capacity we have. This is more a high-level view to let you get into understand what Longhorn has right now. So Kubernetes persistent volume, and sometimes people will come to, can Longhorn support a persistent volume? For sure, this is the first items we need to support. So I want to say we support the different volume modes and access modes. Right now it's broad volume and file system volume, read-write only and read-write many. And I mentioned another one is read-write many, but actually it's broad volumes with the migration capacity. So this is what I mentioned initially. If you want to use your like a Kuber, and together with the you can migrate your VM volume around. This is the mode you can use. And CSI protocol, we try to fulfill all the capacity we can do. Volume, provision, attachment, snapshot, clone, and expansion. And I know some people come to me, can Longhorn do the volume group stuff? Yeah, volume group right now is to the beta stage. So it's one of items we want to work on. And volume capacity, simple vision, snapshot, more I/O efficient, train expansion, and a lot of things. And most important part is live migration and live upgrade. So the main purpose is no service interruption. And I/O performance V2, V1, data localities, and for the user experience, we have UI. And recent version, we come out with the CLI, but the CLI is not that you to operate the Kubernetes customer resource. No, this is not our purpose, because you already can do it using kubectl. So Longhorn CLI is more about you can install what you need. If you need to install the Longhorn, you can troubleshoot the replica issues. You can move around your replicas. So we want the Longhorn catalyst CLI is more like day 1 and day 2, and also troubleshooting tool interface for you. So this is one thing. And monitoring metrics to understand volume usage, disk usage, and down to Longhorn component levels, Longhorn major our component plans, and Longhorn instant major our data plan to know about metric about it. And storage, the Longhorn disk is managed by V1 will be file system based, and the broad device based managed by the SPDK drivers. Replications, we have anti-affinity stuff, not just long level, not just no level. We just come with the disk level together with the auto balancing. So if your replica is not balanced from the specific usage point of view, Longhorn have a function to let it balance. And storage tag to specify the which disk, which node you want to use for specific purpose. You can come with the specific storage class for it. Data protections, replication, encryption, bureau protections, data service in cluster, snapshot, out of class backup, DR volumes. So a lot of things in backup compression. So I just mentioned the high-level ones, but actually many details if you look into the long documentation. So I probably will not jump into this. I just quickly go through. Some of you maybe already read. So I want to highlight the snapshot chance so we can make the I/O efficient. And most of the part I want to mention is V2 also support this one based on logical volume. Backup, we support the incremental backup initially, but in the last version, one that we support a full backup. Because sometimes if your backup have something wrong, okay? Because your replica has something wrong, and you continue doing the incremental backup, but your backup probably already have problematic. So we allow the user can have a period of time to do a full backup again, and you can do based on your design. So give the people have a more opportunity to control how backup it is. Compression, LD4, so GDIP, few compression methods we provide. 2M block size, and this is by default, but we want to make it configurable because your data may be different type of data. So we want the user can decide what block size you want. For example, you maybe want a larger block size because your data is video streaming or even data processing data. So this is something we want to use because this will be impact and related to your usage and cost for your external backup targets. Okay? And this one is about the live upgrades, actually the same idea for migration. So we want to make the service no interruption. So we will come with the two engines at the same time to make sure standby engine will be ready, target engine will be ready, then you can switch your traffic in between. So it's a live upgrade and live migration. Okay, disaster recovery. In the past, we only support one backup target, but in the latest version 1.8, we support the multiple backup target right now. So because we have a lot of people, the user want to have a backup tiering. They have some data is the cold data, hot data. So they want to have a different manager for the data backup. And also come with the following questions. What's the traffic go through? Is it go through the class network, or can we leverage a Longhorn storage network, have a dedicated storage network for the traffic? For backup right now, no. Storage network only for the data plane traffic, and for the engine and replica. But this is the item we want to do. And V2, just briefly, is based on SPDK high performance and the POL mode. You need to have a dedicated CPU resource for that. And I know that dedicated resource may be a challenge for people. If I just have a low spec, can I also run a V2? Because I want to try V2. So we are investigating the interruption mode, because right now the SPDK is POL mode, polling modes. So we want to investigate is possible to do an interruption mode right now. And few components in the database in the SPDK we are using right now actually support interruption, but some of them not yet. So this is something we are investigating. So I hope we can make it happen soon. And so that means you can use the V2 in the high spec media spec, and even low spec. This is our ultimate goal. And this is a comparison. If you compare with the concept we designed in V1 and V2, logic volume compared with the simple provisions bus files, and RAID 1 BDF SPDK concept compared with our V1 engine, ME&E over fabrics, UBlock, iSCSI, and replication based on ME&E over fabric, or our home mat over TCP for V1. Okay, I only have 30 minutes. So what we have new stuff in 1.8, we can make it configure your CPU core for your data engines for V2. Before V1.8, just one CPU because it's for try. But for now, for performance testing, I know some people want to do a benchmark, so it's configurable. DR volume right now is extending to V2 as well. Auto salvage, if your old replica fail, we can auto salvage your volume, can come back to healthy. Right now, it's also happened to V2. Volume live migration, V2 ready. Volume encryption ready as well. And replica rebuilding more efficient. We're using snapshot checksum. But right now in 1.9, we want to make it better. We want to down to the chunk of data in a snapshot, and we are doing right now. In not just the snapshot level, or even chunk of data levels inside the snapshot. And back image update and download. Back image is a concept for the VM image if you want to use the virtualization stuff. And Talos, previous Talos we only support the V1 for Talos, but right now V2 is ready. And multiple backup and rewrite many automatic volume expansion without service downtime. And ham controller introduced by K3S. And some people want to use the automated way to handle the Longhorn installation and upgrade. It works right now as well. And for upcoming 1.9, UBlock front-end, Delta replica rebuilding based on Delta snapshot, phased volume cloning to reuse the existing snapshot from your V2 volumes, volume expansion, and storage network. In the current status, we are already done almost on UBlock and first volume cloning and storage network. We still have time, so we want to make the remaining item ready for 1.9. And V1 and V2 offline replica rebuilding. Previous, we have a volume offline replica rebuilding for V2, and because this is a workaround until we can make the online replica rebuilding ready. And nowadays, it's ready, but the following request, can we have an offline replica rebuilding? I say, oh, it's interesting, because they want to make sure if even their volume is detached and somehow they are no gone, we still can make sure the replica around. So this is the requirement based on the behind the context. So this is why we want to come with that for V1 and V2. And recurring system backup is the whole long system backup also happens. And benchmark, we use the EQNIX method sponsored by CNCF, but maybe next time will be Oracle OCI. Yeah, because EQNIX method is retired. Okay, so looking to the benchmark, this is IOPS. Blue bar is the local path provisioner to understand the raw performance. The red one is V1 volumes. The green one with V2 volume. Along with your increased number of CPU, you will better understand, okay, the V2 performance is getting better. But of course, there's a penalty between the raw disk and the distributing bar system, right? But it's getting better than V1. Right, IOPS is the same. You're getting more performance gain compared with the V1. And throughput, yes, the same. Especially along with a number of your replicas, you will get more throughputs. This is natural things. And write throughput as well is getting better. If you see, for our testing, we just use a 1 to 4 CPU code to understand how the performance it is. So this is why we come with the configurable CPU counts for 1.8 for the performance testing purpose. Okay, read latency, yeah, V2 is also getting better, but you will see what's the difference. It seems like no different with the number of CPU. Unfortunately, it hit the upper bounds because our testing environment is not good enough. So if you have a better environment, you can give it a try. You will see a difference here. So yeah, this is the same. Okay, so maybe we'll run out of time. If you have a question, you can come later. But I will share some highlights here for the communities, and we will have adapters, MD. I know many people use Longhorn, but I don't know who are using Longhorn. So if you have time, in the following weeks, you can come with your PR to let us know your usage, your feedback. So it will be good to promote the Longhorn project adoption and contribute to a Longhorn. I know contribute to a distributed system is quite hard because he composed different components. But like I say, we have control plane, we have data planes, and I try to make it briefly that you understand how it works. So very want to encourage everyone. You can contribute with the deployment, installation, and upgrade, or even down to the data engine control plane, and CLI as well, or even ecosystem tooling. Because one of the users also shared with me, we can follow up with block change stuff. So this is one type of a contribution. You can come with us, and to let us know your ideas. Okay, so the last one is gap issues. Any issue, report issue, help with issue. These are all about a contribution. So our next step is come to a graduation. So we hope if any contribution from all of you. Okay, thank you. So do we have any questions? Do we have time? No, okay. So I will be here. So if you have a question, come to me and we can discuss. Okay, thank you everyone.